This is the oxidation of alcohols. We can have a primary, a secondary, or a tertiary alcohol. We know for a primary, the carbon, which is attached to the functional group, in this case hydroxyl, has two hydrogens attached to the carbon, which is attached to the functional group. So its primary 1 degree is acceptable. For secondary, the carbon, which is attached to the functional hydroxyl, has only got one hydrogen, so it is secondary 2 degrees. The carbon which is attached to the functional group here has no hydrogen, so that is tertiary. There's no reaction with a tertiary. For oxidation of the alcohol, we can use acidified dichromate in H+. We can also use MnO4- H+ to reduce the ketone back to the secondary alcohol. You can use a lithium aluminium hydride. If you want to go vicious, you can use sodium borohydride to take it back. These reagents work here for secondary, these reagents work here for primary. So for oxidation, again Cr2O72- H+, acidified dichromate, acidified permanganate, and then the reduction lithium aluminium hydride or sodium borohydride will do the trick. These are here and they are here, so not too much to remember. Tertiary, nothing, stays the same. What stays the same we'll come to in a second. Secondary, we have the hydroxyl becomes a carboxyl group, so that's going to be a ketone in the middle of a chain. Then primary alcohol, we have the aldehyde and then we have carboxylic acid. Why do we get the aldehyde first? Well, the aldehyde, as you know, has a carboxyl group. That's delta plus, that's delta minus. What intermolecular forces does it have? Dip-dip, dipole-dipole interactions. If we further oxidize it, we still retain the carboxyl group, but now make it carboxylic with a carboxylic acid. This is still delta minus, this is delta plus. But what do we have now with the OH group? We also have hydrogen bonding. With the addition of hydrogen bonding, this will have a higher BP, boiling point, and a higher melting point than the aldehyde because it has hydrogen bonding. So this one, the aldehyde, we can distill. So this one we can distill, and if we carry on the reflux, which I'll show you in a second, the reflux, we get the carboxylic acid. What other equations do you need to know? You would need to know the certainly the reduction of dichromate to chromium 3+ and the reduction of manganate to Mn2+. As you know, you can use H+, E- and H2O to balance these equations. What do students always forget? They always forget this 2. Don't forget to put 2 there. 7 oxygens, the only thing we can use that has oxygen in it is water. 7 H2Os, now we've got 7 H2s, that's 14 H+. Some students don't like this bit either, so let's take a little while. Plus 14 minus 2, plus 14 minus 2 is plus 12. 2 times 3 plus is 6 plus. How do we get those to be the same? 6 plus, 12 plus, so we need 6 electrons. Now that balances. The second one's easier, 4 oxygens, so we're going to need to have 4 waters, 4 H2O, 8 H+, this side is 2+, this side is 8 plus minus 1, so that's plus 7, so we're going to add 5 electrons to the left hand side. Do you want to see the reaction? No, you can't yet. Why? Because we've got to do the colour change. How did I forget the colour change? When we use dichromate, we go from orange, which is Cr2O72-, that thing, and we go to green. What's he doing to me? We go to green. Thank you. Green, orange to green is the colour change. So it could tell you that this one would stay. This one here, the tertiary, that would stay orange. So if you add dichromate, nothing happens. It's definitely a tertiary alcohol. Good clue in a scientific investigation when you're being a detective and working out the unknown. If it goes green, it could either be a primary or secondary, but at least you know it's not tertiary. Let's have a look at the reaction. The oxidation of ethanol, which is primary, 2 hydrogens on the carbon, 2 H on the C. Not 1 H, which is secondary or tertiary. You know what this is. This Mr. M for chemistry. 200 mils of dichromate, an acid in the flask, 1 mil of ethanol, which could make a little blast. So put in a few anti-bumping lumps or bricks. Let the Bunsen be flame as the flame just licks the bottom of the flask. No hot spots, or your ceiling tiles will come an inferno of hot rocks. When the colour changes from orange to green, your dichromate has reduced to a carboxylic acid scene. So you can comment, like, subscribe at the bottom. You know what to do. Comment, like, subscribe. Thank you.